Vector story problems. All right. So we have Megan, and she is running an obstacle course. The information given tells us some various distances she traveled at angle measures. Ultimately, what we want to find is how far is the start point to the finish line if we went directly there, and what angle would that be? Let's start by just sketching her path. She begins the race by going a distance of 2.4 meters at an angle of 42 degrees. From there, she goes another 5.2 meters at an angle of 74 degrees. On the last leg of the obstacle course, she goes 9.6 meters at an angle of 11 degrees, which would take her to the finish line. Ultimately, we want to add these vectors together to get the magnitude and direction of the resultant. So let's write a vector for each one of these paths. This time I'm going to use linear combination notation. Here's the formula for writing the equation of a vector. I'm calling the first leg of the obstacle course R because I drew this path in red. Substituting the values, I get this. I need to do this for each path, so my second vector is vector B, and I substituted my values. Lastly, the vector representing 9.6 meters at an angle of 11 degrees is as follows. Now that we've written an equation for each vector, we can add the three vectors together. Adding the first components, which are the I components, I grabbed my calculator. Making sure my calculator is in degree mode, I added these three highlighted values. The first component of the resultant vector is 12.6404828I. To find the second component of the resultant vector, I added these orange highlighted values. The second component of the resultant vector is 8.4362406J. Now that we have the equation of the resultant vector, we will be able to find the magnitude and the angle of this resultant vector. The resultant vector starts at the start line and finishes at the finish line. To find the magnitude of this resultant vector, we use this formula. The length of the resultant vector is about 15.2 meters. To find the direction, we use this formula to find theta. Substituting our values in, we get this, and now to get theta alone, we're going to take the inverse tangent of both sides. Make sure your calculator is in degree mode. The inverse tangent of this fraction is 33.72 degrees. Transferring our results to my diagram, the resultant vector has a length of about 15.2. It says round to the nearest hundredth, so I may have wanted to write 15.20 meters. The angle measure is 33.72 degrees.